everyone, welcome to this video. In this video, we are going to see how to solve the type 4 form of nonlinear PDE. The type 4 form of PDE are also known as separable equations. So here the PDE will be of the form f1 of x comma p is equal to f2 of y comma q. So unlike the type 3 form, here we have both x and y along with p and q. So since the function of x and p is equal to function of y and q, we can take this is equal to some constant a. So from this, we can write p as function of x and a and q as function of y and a. Since dz is equal to p dx plus q dy, so here we are replacing p as a function of x and q as a function of y. And then integrating this, we get our complete solution. And singular and general solutions are obtained as usual. So now let us see our first example. Here the question is solve p square plus q square is equal to x plus y. So it is the type 4 form of PDE because we have both x and y along with p and q. So we have the type 4 form of PDE, that is we have a separable equation. So here first we have to combine p with x and q with y. That is, so combining p with x, p square minus x is equal to y minus q square. And then equating this to some constant k, say. So from this we write p as function of x, that is p square is equal to k plus x. That is p is equal to square root of k plus x. And similarly, y minus q square is equal to k. From this, q square is equal to y minus k and q is equal to square root of y minus k. Since dz is equal to p dx plus q dy, so here we replace p and q, so which is square root of k plus x into dx plus it is square root of y minus k into dy. And in the left hand side we have dz. Now integrating this, we get it is square root of k plus x, or we can write the same as k plus x the whole power 1 by 2 plus integral y minus k under square root dy. So now for integration we get z in the left hand side, and in the right hand side, since it is k plus x the whole power 1 by 2, upon integration we get in the power 1 by 2 plus 1, that is 3 by 2 by 3 by 2. So that is 2 by 3 into k plus x the whole power 3 by 2 plus 2 by 3 into y minus k the whole power 3 by 2 plus some constant c. So here this involves only two arbitrary constants. This is what our complete solution. The constants are k and c. So this is considered our complete solution. So for finding the singular solution, so this is what our complete solution. So for finding the singular solution, we have to differentiate this complete solution with respect to the arbitrary constants. So first, when we differentiate this partially with respect to c, we get 0 is equal to 1, which is absurd, which means this equation has no singular solution. And for finding the general solution, we can take c as function of k and then replacing it in the complete solution and differentiating it with respect to that arbitrary constant k, and elimination of k gives the general solution. So now let's see another example in this. So this is our second example. Solve p square plus q square is equal to x square plus y square. So it is type 4 form of PDE because we have x and y along with p and q. So here We combine first p with x, that is p square minus x square is equal to y square minus q square. Since these two are equal, we can say this is equal to some constant k, say. So now from this we write p as a function of x, that is p square is nothing but k plus x square, and q square is equal to y square minus k. From this p is square root of k plus x square and q is square root of y square minus k. So now we have dz as p into dx plus q into dy. So now replacing p and q in this, we get square root of k plus x square into dx plus square root of y square minus k into dy in the right hand side, and in the left hand side we have dz. So now integrating this, we get z in the left hand side, and in the right hand side it is x by 2 square root of k plus x square plus a square by 2, that is k by 2 sin h inverse of x by a, x by root k, plus in the second term it is y by 2 square root of y square minus k, plus it is a square by 2, sorry, minus k by 2 cos h inverse of y by root k, plus some constant c. So which is our complete solution. So now differentiating this partially with respect to c, we get 0 is equal to 1, which is absurd. So for this equation we have no singular solution. So singular solution does not exist here. Solution does not exist. And for finding the general solution, we can take c as function of another constant, that is c is equal to function of k, and then differentiating the complete solution with respect to k, and then elimination of k gives our general solution. I hope you understand how to solve the type 4 form of nonlinear PDE. So let us meet in our next video. Thank you.